Hello, welcome once again to Chemistry Mail. Today on Chemistry Mail, we are going to look at Electrochemistry Part 5. Remember that we started electrochemistry from the meaning of oxidation and reduction. And so far we have looked at the concept of oxidation number. We have also looked at how to calculate oxidation number after we looked at rules guiding oxidation number. So in the last class, we solved some examples on calculation of oxidation number. And today, we want to solve one of the questions or two of the questions that we gave as takeaway questions in the last class. Subscribe to our YouTube channel and make sure that you follow us on Facebook at Mathematics and Science Mail. All right. Without taking much time, let's do justice to these two questions. We are required to find the oxidation state of chromium in K2Cr2O7 and also to find the oxidation state of phosphorus in PO4 3-. All right. If you have watched the previous video, you will understand the steps that are involved in finding oxidation state or oxidation number of an element in a given compound or radical. So let's quickly look at the first question. Let's look at the first question. We are required to find the oxidation state of chromium in this compound. Actually, it's a compound because there is no charge here, but this one is a radical. We explained that in our previous videos. So we said for us to find the oxidation state of an element in a compound or radical, the first thing we need to do is to take note of the compound or the radical. Then after taking note of the compound or radical, we need to identify the key elements. So we have taken note of this. This is a compound, like I said earlier on. There is no charge on this, so it's a compound. But here, this is a radical because it carries what? A charge. When we have group of atoms with charge, that's what we mean by radical. So we have taken note of this compound. The next thing is to identify the key element. The key element is the element we want to find its oxidation state. So in this case, the key element is what? Is chromium, because that's the element we want to find its oxidation state. So the next step after identifying the key element will be to represent the oxidation state of the key element with a letter, and then we use basic rules or appropriate rules in the rules guiding oxidation state of numbers of elements to write out the oxidation state of the rest of the elements that are in the compound. So the key element is chromium, so I can say let oxidation state of chromium, that's Cr, be X. So we say we have to use a letter to represent the oxidation state of the key element. That's the element we want to find its oxidation state. Then the next will be, using appropriate rules, find the oxidation state of the remaining elements in the compound. Now we have potassium. Now the oxidation state of potassium is going to be +1 because potassium is in group 1. We explained that in the rules guiding oxidation state. And the oxidation state of oxygen is -2 because we said that the oxidation state of oxygen is -2 in all compounds except in what? In peroxides. And in that video, that should be part 3 of electrochemistry. In that video, we explain what we mean by peroxide and why the oxidation state of oxygen is -1 in peroxide. But in other compounds, oxidation state of oxygen is -2. So here, the oxidation state of oxygen will be -2 because this compound is not a peroxide. So after we have represented the oxidation state of the key element with a letter, and we have also used appropriate rule to determine the oxidation state of the remaining elements in the compound, the next thing we have to do is to sum all the oxidation state and equate it to 0. Since we are dealing with a compound, we said for a compound, sum all the oxidation states and then equate it to what? To 0. So because we are dealing with a compound now, so we are going to sum the oxidation state. Potassium is +1, and we have 2 atoms of potassium here, so ×2, plus chromium is X already, so ×2, and then oxygen is -2, and we have 7 atoms. Equate everything to 0. Why? the sum of the oxidation states of all the elements in what? In a compound is equal to 0. So as we sum the oxidation states of all these elements in a compound, we're going to equate it to 0. So, having done that, this times this will give me plus 2 plus 2x, and this will give minus 14 is equal to 0. So we can gather like terms now. So we have 2x equals 0 plus 14 when this moves here, and then plus 2 over here is minus 2. So 2x will become 0 plus 14 is 14. 14 minus this will give me plus 12. Therefore, we can actually get our x. So x becomes plus 12 over 2. X will give me plus 6. So the oxidation state of chromium in this compound is what? Plus 6. So oxidation state or number, oxidation state of chromium in K2CR2O7 is plus what? 6. Remember that we said one of the rules guiding oxidation state is that the oxidation state must be written with what? With signs. So that's why we have to include this plus 6 there. Okay. So this compound is actually potassium heptaozo dichromate 6. Dichromate 6. So that 6 is because of this. Alright. So that's on question number 1. Then on number 2, we're asked to find the oxidation state of phosphorus. This is a radical, so we take note of the radical. So I can say, let the oxidation state or number, remember oxidation state is something as oxidation number. So let the oxidation state of phosphorus be Y. So let it be Y. And the remaining element here is oxygen. So oxidation state of oxygen is already minus what? 2. It's already minus 2. So the next is to sum the oxidation states of all the elements here. So that of phosphorus is X plus, that of oxygen is minus 2. And we have 4 atoms of oxygen here. So we multiply by the 4. Now in this case, we are not going to equate to 0 because this is a radical. So for radicals, we add all the oxidation states of all the elements in the what? In the radical, and then equate to the charge on the radical. So which charge do we have here? Minus 3. So we're going to have x minus 8 equals minus 3. So this will give me x equals minus 3 plus 8, and x will give me what? Plus 5. So the oxidation state of phosphorus here is plus 5. So oxidation state of phosphorus, oxidation state of phosphorus in PO4 3 minus is what? Plus 5. That's why this is tetraozophosphate 5. Tetraozophosphate 5. You remember that in our second video when we considered oxidation, the concept of oxidation number, we said that one of the applications of oxidation number is that we use it in the nomenclature of inorganic compounds. Alright, I believe that the solution is very clear to you. In our next video, we are going to look at another aspect of electrochemistry. This time we will be considering the concept of reducing agent and oxidizing agent. They are very important agents in the study of chemistry. You know that every branch of study, they have their own agent. So chemistry has reducing agent and also what? Oxidizing agent. Don't mind me. So in our next class, we'll be looking at reducing agent and oxidizing agent. Please make sure you don't miss that particular video. If you have not subscribed to our channel, subscribe so that once the video is uploaded, you will be able to have access to that video. Thank you for watching our video today. I'm still your friend, your tutor, and your brother, Engineer I. Okechukwu. I love you.